Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome again to the TV learning programs. This is Teacher Pascal, your chemistry teacher. Today I will be with senior 2 students. We are continuing with unit number 7, the mole concept and gas laws. And today's lesson is the stoichiometric calculations. So before we explain what is stoichiometric calculations or the meaning of stoichiometry, I want us to go through the objectives of today's lesson. And before diving deep in the lesson, we will have a revision exercise to help you recall what we have been discussing in this unit. So here we have the objectives of our lesson. At the end of this lesson, you should be able to work out various exercises involving stoichiometric calculations. And as I said, before we go into the calculations, we will have to explain what is stoichiometry. And the revision exercise we have is here. In the previous lesson, or the last lesson we started in this unit, I gave you a homework, an assignment, and I hope you've had enough time to go through the exercise and work it out. So we have some of those exercises that we are going to correct right now. And for those who didn't get time to try the exercise, this is the right time. You can use this time to try them. So you take let me give you some seconds, and you try exercise number 1. I read it for you. Use these mass numbers, values, or relative atomic numbers. We have carbon, which has 12. We have oxygen with 16, and sodium with 23 to calculate the mass of 0.050 moles of sodium carbonate. You are going to use those mass numbers, and you calculate the mass of that number of moles of sodium carbonate. Remember, using those values, we can determine the mass number of a molecule, the molecular mass when we have 1 mole. So if we can determine the molar mass of this compound, that will be the mass for 1 mole. So you can use that and the value of moles we have here to determine the number of moles for this substance and the mass corresponding to this number of moles. How do we deal with this? So the answer is this one. We have sodium carbonate. The molar mass is given by 2 atoms of sodium. For sodium, we have 23 times 2, plus we have 1 atom of carbon, that is 12, plus 3 oxygen atoms, that is 16 times 3. Then here we get 48. Here we have 12. And here we have 46. And what do we get? 48 plus 12, that is 60. Plus 46, that is 106 grams per mole. And to find the mass, the question is asking us to find the mass. So the mass, which is given by molar mass times number of moles, will be 106 times 0.05. That is the value we have. The value we have here, 0.05. And what do we get? You also have to learn how to use your calculators. So let me give you some seconds. you work out the answer for that question, and then you write it down. Me too, I will use my calculator and give you the right answer. Ready. So we have 0.05 times 106. And what do we get? 0.05 times 106, we get 5.3 grams. So this is the mass of 0.05 moles of sodium carbonate. And question number 2, a compound of carbon and hydrogen contains 85.7% carbon and 14.3% hydrogen by mass. Deduce the empirical formula of this hydrocarbon. Mass numbers we have, it's for carbon, which has 12, hydrogen has 1. Here it has been, what we have been given is oxygen, but for hydrogen, we use 1. Hydrogen has 1 and carbon has 12. And how do we deal with this one? The question is also asking to find the molecular formula given the molar mass to be 70 grams per mole. And the first thing to do here is to find the empirical formula. And that is what has been asked. So let us find the empirical formula. You remember the steps of finding the empirical formula? You find the number of moles, and from the number of moles, you determine the simplest ratio, which is the empirical formula, and from there, you can find the mass of the empirical formula, and when you take mass of the molecular formula over the mass of the empirical formula, you can determine the multiplicator you have to use to find the molecular formula of this compound. So let's start with the number of moles. For carbon, we have the percentage is 85.7. So this, in a sample of 100 grams, we have 85.7%, which is for carbon. And for hydrogen, we have 14.3 over 1, and what do we get? Use your calculators, please. Here we get 85.7 over 12. We get 7.14. 7.14. And we have 14.3 over 1. The answer is 14.3. Now we find the simplest. To find the simplest ratio, what do? We divide the number of moles by the smaller one. So for carbon, we have 7.14 over 7.14. And for hydrogen, we have 14.3 over 7.14. And what do we get? In each case, for carbon, we have 1, and for hydrogen, it is approximately 2. We have 14.3 over 7.14, that is 2. And then the empirical formula will be CH2. CH2. Now, we have the molar mass, which is 70. And to find the value of N, we have 70 over molar mass of the empirical formula. What is the molar mass here? We have 1 carbon plus 2 hydrogen atoms, and that is 12 plus 2, which gives 14. So we have 70 over 14, which gives 5. And the molecular formula becomes CH2 times 5. And in that case, we get C for carbon, we have C5, and for hydrogen, we have H10. So this is the molecular formula of our compound. The molecular formula of our compound. Now, we have to write the balanced chemical equation for the reaction of potassium chlorate when it is heated and decomposed to form potassium chloride and oxygen gas. The balancing of chemical equations will help us to carry out the stoichiometric calculations we have been talking about, the title of today's lesson. So let's start. We have potassium chlorate decomposing when heated to produce potassium chloride plus oxygen. This is solid, and oxygen is in the gaseous state. And here we have 2 oxygen atoms, but in the reactant side we have 3 oxygen atoms. Let us put 2 here. If we put 2 here now, we have 6 oxygen atoms. With the 6 oxygen atoms, if we want to get the same number of atoms in the product side, then we multiply by 3. Okay? We multiply by 3. And like this, our oxygen atoms are balanced. And what about the potassium atoms? We have 2, and even for the chlorine atoms, we have 2 in the reactant side, and here we have 1, so we multiply by 2. So our equation is well balanced. And let me tell you one thing which is very important. To carry out stoichiometric calculations, you have to remember to be able to balance chemical equations. If you can't balance chemical equations, you have to revise that. We have been studying this in Senior 1 and Senior 2, so please remember to revise that every day. It will always help you when you want to carry out stoichiometric calculations. Now, let us start with the introduction, which is going to explain how or what is meant by stoichiometry. This is a word derived from 2 Greek words, stoichion, meaning element, and metron, which means measure. We can carry out some measurements, quantitative measurements of elements in a given equation. So it deals with the calculations of masses in a compound. Or in a given reaction, we can determine the masses of various compounds, be it the reactants or be it the products. If some of the reactants are known, their quantities are known, then we can use balanced chemical equations to determine the masses or the quantities which are unknown. I will give you an example. Let's say that 2 people pay 1,000 to move from Nyabugogo to Kimirongo. It's an example. We are saying 2 people pay 1,000 to move from Nyabugogo up to Kimirongo, or to move from place A to place B. Now, if we know that 2 people are paying 1,000, and now we get 5 people, in a simple way, we can determine the amount of money that 5 people will pay, because we know what corresponds to 2 people. So in the same way, if we have a balanced chemical equation, we can use the balanced chemical equation to determine the masses or the quantities which may be unknown if some of the quantities in the balanced equation are known. So that is what the stoichiometric calculation deals with. And here it is said, before understanding how to calculate the amounts of reactants required or the products produced or formed in a chemical reaction, let us study what information is available from the balanced chemical equation of a given reaction. So here we use this chemical equation. We have CH4. CH4, this is methane gas. It is a combustible which is found in Kivu. We produce carbon dioxide plus H2O, which is liquid. You can see we have 2 moles of oxygen, and here we produce 2 moles of water. Now let us analyze the information provided by this balanced equation. The information provided here, on this side we have, that is the, let's say, the left-hand side, and this is the right-hand side. Here we have products. Here we have reactants. You can see that reactants are related to the products by the use of moles. For example, we can see that 1 mole of methane gas needs 2 moles of oxygen to completely burn. And when it burns completely, we produce how many moles of carbon dioxide? We produce 1 mole. And here we produce 2 moles. Now, let us say that I have 3 moles of CH4. How many moles of oxygen am I going to need using the balanced equation here? For 1 mole, we need 2. For 3 mole, we need the double. Because for 1, it's the double. So for 3, it will be 6. Okay? Now, how many more will be produced for carbon dioxide? We produce 3, because 1 mole of methane gas produces 1 mole of carbon dioxide. And in the same way, from this, we can determine the number of moles of water that will be produced. 1 mole produces 2, or 2 moles of oxygen produces 2. So 6 will produce 6. This is how we deduce what we have in a balanced chemical equation. Now, you can see that there I'm using the number of moles, but it is the same as using the volumes or masses. But for volumes, you have to make sure that you are working under same conditions of temperature and pressure. Now, if we use the masses, here we have carbon combined with 4 hydrogen atoms. That will be 16 grams. Now, 16 grams need how many grams of oxygen? You can also determine the mass of that oxygen. So you can use the known masses to determine the masses which are unknown. You can use the known number of moles to determine the number of moles which are unknown. And quickly, let us have a worked example. Worked example number 1. Worked example number 1, how many grams of oxygen are required to completely react with 0.200 grams of hydrogen to yield water? Also, calculate the amount of water formed. How many grams of oxygen? Here you have to be very careful. There is nothing we can do if we don't know the balanced equation for the reaction which takes place. So for the reaction which takes place, we have hydrogen, which is a gas, reacting with oxygen, which is also a gas, to produce H2O, which is liquid. Okay? Now, is our equation balanced? That is the first thing to check. Because if the equation is not balanced, then your stoichiometric relationship will be wrong. And the mole ratios, they are the ones we have to use to carry out right stoichiometric calculations. So we have 1 mole of hydrogen or 2 hydrogen atoms, 2 hydrogen atoms. But for the oxygen, we have a half. So we use a half. Now, it's very simple. Let us start by determining the masses. What mass of hydrogen do we have here? What mass of oxygen do we have here? For hydrogen, we have 2 grams per mole. 1 mole of hydrogen molecule. And for oxygen, we have 16. 16 because we are using a half. Okay? And what do we produce when we take, do you remember the law of conservation of matter or of mass? You can see if we take 2 grams plus 16 grams, we should get 18 grams. And what is the mass of water do we produce? Here we have produced, for oxygen, it is 16 plus 2 for hydrogen, and that is equal to 18. So here we have produced 18 grams. Okay? Now we can see that 2 grams of hydrogen produce 18 grams of water. And let's go back to the question. How many grams of oxygen are required to completely react with 0.2 grams of hydrogen? Here we have 0.2 grams of hydrogen. For oxygen, that is the question. And the question is also asking to calculate the mass of water that will be produced. Okay? Now, we know that 2 grams of hydrogen react with how many grams of oxygen? 16. We have it here. 2 grams combined with 16. Now, if we have 1 gram of hydrogen, it will combine with 16 grams over 2. And if we have 0.2 grams of hydrogen, this will react with 16 over 2 times 0.2, and what do we get? You can use your calculators, and here is what we get. We have 16 over 2 times 0.2. And we get 1.6. 1.6 grams of oxygen. So when we have this mass of hydrogen, we need 1.6 grams of oxygen. And the other question is to find the mass of water produced. So the mass of water produced will be equal to 18 grams over 2 times 2 grams produce 18. So it is 18 over 2 times 2, 0.2. And what do we get? We get 1.8 grams of water. That is what we get. And here we have work example number 2 that you are going to try. What mass of zinc is required to produce hydrogen by reaction with HCl, which is enough to produce 4 mole of ammonia according to these reactions? These are the two reactions we have, and I hope you can try this one. And the other example we have is 10.6 grams of solid sodium carbonate reacted completely with hydrochloric acid to produce carbon dioxide, sodium chloride, and water. This is very simple. And what I'm going to do for you is that I'm going to write the balanced equation. We have sodium carbonate reacting with HCl to produce sodium chloride plus carbon dioxide plus H2O, liquid gas in aqueous state, and aqueous state. How many sodium atoms do we have here? We have 2, so we balance like this. And now we have 2 chlorine atoms, we balance. For hydrogen atoms, it is balanced. Carbon atoms, it is well balanced. And with the balanced equation, that is sub-question A, you can calculate the mass of hydrochloric acid needed for a complete reaction, and you can also calculate the mass of each product formed. It is very simple. This is what you will do as your assignment, and we will start with this one when we will be studying the next lesson. So you will calculate the mass of hydrochloric acid and the mass of each product formed. Remember, you use stoichiometry. From what is known, you can determine what is unknown by using the balanced equation that I have already given you. Thank you very much for your participation. Thank you very much for your attention. I hope the lesson was very clear and you understood everything. See you next time.